Hi folks, this is Craig here from East Coast Metal Structures, and welcome to my video on cage ladder drawing styles in advanced steel. I want to start off by saying that my goal for any drawing that I create for the shop is obviously to be fabricator friendly, number one, and also to have minimal clutter, giving all the information but nothing else. And typically any drawing style, with the exception of gather sheets, out of the box on most of these parametric detailing softwares, most of the drawing styles are going to be cluttered with just pretty much everything thrown at it, as far as dimensions and just all kinds of stuff that you really don't need, and you have to pick through and delete, and it becomes very time consuming to basically scrub the drawing styles out of the box. So you'd be best served to create your own, and in order to do that, you have to acquire a deep understanding of the drawing style manager, and especially how model roles of the objects are used. And you can create your own model roles to make dimensioning requests more precise. But we'll go over some of that here, and I'll show you exactly what I'm talking about. Here's the ladder type that we build. This is an all aluminum ladder. It uses a 2x1 channel for the rungs, and that's an extruded channel. If you're to look at the actual exact configuration, it's got some step or non-skid kind of raised surface here. This is a profile that I created and inserted into the ladder macro, and that is the aluminum rung that we use. We use a standard aluminum grating from McNichols, and also the platform floor itself is encapsulated by or the grating is held in place by some angle, and then that's welded to the actual ladder stringers or ladder profile, if you will. And then the hoops are 1/4x3, and then the rest typical are 1/4x2. And then we have ladder standoffs that are 3/8 of an inch, and they're just bent plate, basically utilizing some kind of an expansion anchor. Okay, so this is the over the parapet cage ladder style, and we don't bother doing any kind of radius top here. It's really, it looks better and it's a little more comfortable ergonomically, but it's as far as fabrication goes, it just requires more prep and setup. You've got to cut these pieces to the proper length. We have water jet capability and a plasma cam as well, but again, it's just something we don't elect to do. It'd be kind of difficult to bend these 1x3s the hard way anyway on any kind of rolling machine, so we just go straight across and miter the corners up top. This right here is an example of a over the parapet ladder with a platform with no cage, and those are the two I'm going to be using for this example. Now, what I'm going to do first is I'm going to show you the out of the box drawing style, okay? And this is in the Advanced Steel database. It's called ladder. Hit use, and I'm going to select my main part. Now what I'm going to do is I'm going to go in here and modify this, because I've actually, as far as the prototype goes, I've created a portrait type prototype, a D size for my drawing style, but I'm going to go back to the D size assembly prototype. And what it's going to do for me is it's going to give me a ladder out of the box. We'll wait for that to render up, and then I'll show you what I mean after I open it. Alright, cancel out here and show assembly detail. Okay, now this is the out of the box style, and again, if you're a good fabricator, you might be able to figure this out, but it's really a train wreck as far as really being organized or being clear and concise. So let me go ahead and go back into the model, and I want to show you what my drawing style looks like out of the box or at first run. Now, 90% of these drawing styles that you create, especially with more complex assemblies, you're still going to have to scrub a bit. And it's one of those things where there's some enhancements that Advanced Steel the developers could introduce into the drawing styles that might aid in less scrubbing, but ultimately you're going to have to scrub something. I mean, the key is getting to a point where it might be like a 90% complete or an 80% complete. That would be a nice number, where it may only take you 5 minutes to scrub a drawing like that, and having everything else put into place. All right, so here's my ladder with cage. And one thing I want to make sure of is that, I've created these views, these custom views, and I also have a sectional view here. And what I want to make sure of is that I have the ability in the section views to select my cuts interactively. Now, if you go to any section view and you go to the view properties and this choice of view, you can either have always or interactive. And depending on the size of the run, if you're running a process, or if you're running a suite, if you want this to be automated, it's going to select the cuts that are basically parts that are welded to the main part. And so if you have a spacing for your cuts that's small, it's going to select a bunch of different cuts, and you're going to wind up with a bunch of cuts automatically on your drawings, which is if you're going to run a process, you're going to want to probably have those automated so that you can just go back into the drawing when you're scrubbing it and delete those cuts and only save the ones you want. If you're running a singular drawing or just a couple, 2 or 3 ladders, you can make this interactive so that you can actually select the cuts, and that will create a drawing that's where the cuts or the sections are only the ones you've intended. So, but I'll get into that a little bit more later. Now, I've created that drawing and also put it into a process. Now, what I'm first going to do is I'm going to select the main part of this ladder, and I'm going to go into my processes and pull this out here. Now, basically, I have a section. I've created these different processes, and I've developed them and set them into different folders. But this is my ladder folder, and I've got some other things in here for the ladders. But if you'll notice here, it's selected ladder with cage assemblies, Arch D. Okay, and this process is going to call up my my portrait D size sheet. And I've got a way that I name my sheets as well, and I'll go over that in another video, but this is a great way to organize your doc manager, which has kind of limited organization as far as folders and things like that, but you can organize your parts and your assemblies into named groups where they're listed in the same columns that are close to each other, so at least you have some way of tracking your drawings through there quickly, and like I said, I'll go through that in another video. So basically my process here is going to show me what prototype I'm using, the selected main part, my main step, which you can drill down to as well. And then I've got my detail style map, which is one that I've created. And if you go into if you drill down into this a little bit, you'll notice here that it's assemblies with cage. And the model object is a main part ladder profile model roll, which is, one that I've put in there. And then my drawing style is the ladder with cage. Okay, so I'm going to hit use, and basically, here we go. It's drawing number 1. Hit OK, and it's going to ask me interactively for the sections. Now, these are the sections that are automatically plotted, and there's a setting in the management tools that allows you to increase or decrease this distance. And I can't remember what I've had it set at, but out of the box, I think it's set at like 6 inches or something, which is way too small, and it basically picks every part that's welded, to the main part. So you don't really necessarily need that with this particular style. So what I'm going to do is I'm going to select a section that grabs this typical radiused hoop, and also I'm going to select a section that grabs this atypical hoop, which is the large one down at the bottom, and then I'll select one that grabs the bottom of it, the bottom of the ladder, showing my standoffs and just a view of that ladder in that respect. I don't need to grab the top one because this hoop right here is included here, and it would just be an extra section I don't need. So I'm going to go ahead and select this, and if you notice here, you can see where the cut is going to be made. Okay, so let me select that guy. I'm going to go down here to my atypical larger hoop, And then I'm going to go down to the last part of the ladder here. I'm going to right click the mouse, and then it's going to create my drawing. Now remember, I've created this drawing on a portrait sheet, D size, and I'll show you in the drawing style where I've been able to rotate the views to where they're perpendicular instead of straight up and down. Excuse me, instead of horizontal like before on the original drawing style. Alright, so I'm going to go over here to my main part, and I'm going to say open the assembly detail. Now if you're wondering why there's a couple of different assembly details, I've got in my main my management tools, I've got duplicate shop drawings set so that I can experiment and not have to erase an assembly drawing every time I create another one. So I'm going to go ahead and select my new assembly style. Now this right here is my style. Now it's centered on the sheet because I want my scale to be a little larger than what would be automatically detected, so it kind of displaces it off the sheet, but that's set in your processes. So now if you'll see here, I've got basically what I have here is a front view, a top view, and then another front view, but this is with the entire ladder system set at environment and only the cage shown with running dimensions, so that when they go to focus on putting the cage together, they can have an unobstructed view of it. This particular view over here also takes into account all the welds that are in place, and the rest of them don't have the welds, just to minimize the clutter. Now I've got a section view here of the 3 sections I just grabbed. It would be the first one here, which was the section C, and that basically had the grading and that typical hoop, and then this one is for the larger hoop down at the bottom, and then this one was for the very bottom of the ladder. Now looking at this drawing, I mean, there's most of the dimensions are in place. There's some scrubbing to do, so I'm going to quickly scrub this thing, and I'll show you how fast I can have this up. You know, I'll take some of these dimensions, I'll move them in. These 2 dimensions here represent the distance that I want that platform to be offset from the ladder stringers. Here's a label that's a little out of place. This label is to signify to ship loose my standoffs on the back side. Here, my rung spacing, this is one of these things with just formatting of the text and the dimensions. The rung spacing text is a little off. I'm going to pull that guy over here, that label. Here's a typical dimension from the middle of the ladder rung to the wall, and that's an important dimension. Usually the minimum for code is 7 inches. Now I'm going to go over here to this guy, and I'm going to have a look at what I can correct. Now I've got some of these things. You'll see when I actually turn this into a PDF that the environment settings they basically gray out to some degree the parts that you really don't want to be in focus, and that's a great tool for focusing on things and listing things in the drawing, but basically leaving them out of focus, so that the fabricator doesn't kind of have that clutter. Now here's another deal right here. The rung spacing is over. Pull that down a little bit. Here we go. I'm going to pull this out so it doesn't collide with that running dimension. You notice here that I've got my rung spacing is at 26 at 1 foot equals 26 feet. Now you can set this this dimension up for any different kind of ways. I've got group equal distances here, and you notice here when I turn that off it brings them back, so I'd rather have a clean drawing. This count for these particular parts that are stacked on each other, they're going to actually give us a setting that will allow us to turn this off, which, because it's quite annoying, you really can't do anything about it. So in the upcoming 2019 they'll have a setting that will allow us to turn this off, which is really nice. And again, here's another rung spacing text that I'm going to go ahead and put directly under there. So, and I'll move this down just a little bit. And let's go over here and check out the welds. Maybe I'll pull this guy over here a little bit. And I should have written typical on that weld, but I'll get that later. Now here's a little bit of a mess here. So what I'm going to do is I'm going to take this, pull this guy up, and I'll pull this down, and then I'll go ahead and try to kind of put those into place where they can be easily read. Pull this guy down like that. I've got a weld. Now I've been meaning to actually go in and correct the position of these labels, but I haven't done it yet, so I'll get to that. Video. Hold on a second here. I'm going to move these up, put them right about here. I'm going to pull this guy down a little bit. All right. And again, we have running dimensions on the cage spacing, if you'll notice, and everything else looks pretty decent. Again, here's a weld detail for the actual rung itself. And now up here, dealing with these, I'm somewhat happy about the placement on these labels. I've set up a label style that keeps them tight to the part, and I typically would like to move these in, okay? And also, for some strange reason, I'm getting multiple radiuses where I was under the impression that the radius dimension was only supposed to call on the system line, but unfortunately it's not doing that here, and I'm not sure why. I've created these dimensions from the center line of the rung to the outside, so that when the fabricator looks at this, he can understand that these are the kind of the outside dimensions of this hoop. Also created to isolate the grating frame angle. I mean, I could set this grating up with no hatch, but I kind of like the looks of it. And again, we have the center line of rung to the bottom of the standoff here. I want to try to move these in close, and you'll see why a little bit later. I want to move these angled callouts to the inside and pull this over. This guy right here. Move that angle callout into the inside, and here's a tread callout that is going to be on the outside here. Then I'll pull the stringer labels to the outside. Okay, now what this gives me is a pretty good description of what's going on with this platform frame. Okay, and again, I have the welding called out here. This is a typical, so I would create a typical annotation there next time I go back into this. All right, one other thing that I want to add manually, which I still believe you can probably perhaps add automatically. I'm going to go ahead and add an angular dimension here. I'm going to go to the center, select this guy, and I'm going to select an area where I want the actual dimension to wind up. Then I'll go here, right here, and here. Now you notice that I'm only doing one side, and that's really all you need to do, because the fabricator is going to assume that that's a mirror. Okay, and then I'm going to go ahead and create an align dimension from here to here. Okay, now that's set up pretty nice. I'm going to do the same with this one, because it's a slightly different radius. So selecting that point where that ladder brace is, this is where I want my dimension to stand, and then selecting these points. All right, now what I'm going to do is I'm going to take one of these radiuses and delete it, one of these radius dimensions, and it's going to be this guy right here. All right, I'm going to go ahead and pull this guy right here. Now that pretty much covers, with the exception of maybe moving some of these labels in. All right, and then we've got your basic hoop call out there. We'll pull this guy in, make it look a little sharper. All right. Same thing here. I'm just going to leave this as is. I don't need to call the width out because it's already done. Okay, so basically these dimensions all through here are directly related to some model rolls that I created, because it's very difficult to get, with all this stuff named ladder profile, it's very difficult to get these things to do what you want them to do. And basically the same thing with the rungs. You've got problems with points crossing over, And just basically, if you don't create your isolated model rolls, it's very hard to get this to work the way you want it to. So, okay, I've got all the points and things scrubbed up quickly. Now I'm going to go ahead and create a PDF for you, or at least a preview of a PDF. And I want to show you how the environment settings on some of the components works out. Okay, and it works out real nice actually. Okay, my concrete is environmental. The actual anchors are environmental as well, so they're going to be faded. Now here's this example of a focus on the cage itself, and you've got your ladder structure that's environmental in this particular view. So it's faded out nice, and you don't have the clutter, the eye clutter basically, but you do have the exact specifications and welding schedule for the cage and the dimensions and things. Up here you'll notice everything's legible, it's easy to read, and they can build from this. Same thing, these sections, and this looks pretty sharp. And that was put together with fairly minimal effort compared to starting from scratch and doing it all yourself. I mean, we're talking about laying this thing in here with minimal effort and minimal scrubbing, which is nice. I've got my my drawing structure list. I've incorporated a call out list for the anchors and for the bolts. And same with my drawing list here, because the McNichols name is, or description is so long for these. And this was one that I put in a group of aluminum grating that I put in myself. And I created my own prefix for it. But basically, it's longer, so you have to actually go into your drawing structured list and change it to be slightly longer so that it doesn't collide with the rest of the stuff going on over here. Again, the grade is mill finish aluminum. I could simply change this to all 60, 63. It's really up to you about what you want to do in your model browser or whatever. And then I've got my own custom title block here with a revision table, and this is what they like to use. So that's what we're working with. Also, my my coating and welding material, all that kind of stuff, I've got that set up in my project attributes, because I've found I'm always having to struggle with the token, the coating or material token in the drawing styles. For some reason, it'll give you none when there's none, and it'll just group a bunch of them together, and also it won't update half the time. So I'm sick and tired of messing with it. So I've basically created the user or project attributes for these. So I haven't filled them in yet. That's why they're blank. All right, so getting back to this. Now that we've got that finished, let me show you how I went about creating the model rolls for this, okay? Now I've got rollover tooltips activated, and you'll notice here, at least they're supposed to work, right? Here we go. Yeah, okay. You'll notice here that I've got model rolls. Now, everything that I'm going to show you here is out of the box model rolls for this particular macro. This is model roll for ladder brace. This will be for ladder bands. These front pieces right here are going to say ladder profile, and your rungs are going to be ladder step. Now these are out of the box. This right here is going to be wall connector, another out of the box assignment for a model roll for this particular macro. Same thing, well, those are basically the components. Now the model rolls that I've created and added to make this thing work properly is the top here. Now this is a ladder platform horizontal top. That's my ladder platform. So basically I'm taking the factory model roll and creating a different one and assigning it to it. The same thing over here. This ladder platform horizontal is another model roll, and that goes for both sides. And then this right here are going to be the ladder platform angle. Now, to isolate the ladder profiles to make dimensioning more accurate, especially with your dimensioning requests, I've created the back side of these ladder profiles. It's called ladder profile short side, okay, and that's both of these are that. And as far as the rungs go, to get independent running dimensions on the rungs, I've created the ladder step short side. So anything on the back side of the parapet is going to be called short side. Same thing here, you got wall connector short side. So just building upon what we already have as out of the box model profile or model rolls, I just add an extra description onto it and create another one so I can get more accurate dimension requests. Okay, now I want to talk a little bit about the drawing style itself, and some of this can get pretty confusing, and believe it or not, if you've ever tried to narrate through some of this, it's pretty difficult to explain. I mean, my mind's eye will see this stuff pretty clearly in most cases as I learn to speak the language of the drawing style manager, but sometimes you can kind of trip over yourself trying to explain it, so bear with me. Okay, I'm going to go ahead and switch to the drawing. And what I've done here is I've taken these labels to these parts that I've created model roles for, and went ahead and changed them to the actual model role, so we can discuss this a little bit. Let's see. Let me go into the drawing style here, and first of all, I want to talk a little bit about the object representation and the importance of that. To give you an example here, on the front, the ladder front, which is basically, and remember when I talk about front, top, front cage or ladder section, these are views in relation to the main part, and that's one thing you have to kind of get through your head, is that the main part front view is basically looking at the main part's front view. Or the beam itself as it lies down on a flat surface, its front view. And these little icons here, or graphics, will kind of help you understand that. Because basically this will tell you exactly what the orientation is of the construction plane, which is important because that's the way it projects. So you'll have to kind of get to know this. It's a little bit difficult to explain, but get to know it because it's very important. If I go back to the model itself, this might help. And let me go ahead and expose the construction plane of the main part assembly. Now I'm going to select the main part, and I'll right click the mouse, and I'll say show assembly construction plane. And you'll notice here that it's basically in this orientation. Now when I rotate that around, you'll notice that it's right in the center of the part. Now what this is, ultimately, it's the x-axis is running a long ways on this part. So if you were to lay this part down flat, it would give you this look here. Okay, so this is basically the front view. So when I look at the front view of this part, it's with this orientation, or the assembly, the main part, it's with this orientation. This is the front view. The XY plane is, you're looking down on it, and this is basically the Z direction. Okay, it's kind of hard to get your head around, but especially as you start changing these projections, or these view directions. But that is ultimately what you have to learn to understand, and once you grasp that, it makes it a lot easier. So let me go back to the drawing real quick. I'm going to pull up the drawing again, the drawing style, and a little word about the object representation. Let's take the front first. You'll notice that this front ladder representation doesn't have a cage, and what I did was I take the cage, and I'll group the entire components of the cage into one model object. So basically it's a set of components. You'll see here ladder cage, and it basically has the two model roles that the cage consists of, and it's grouped in this model object called ladder cage. Now you notice here that first of all I've turned it off, so basically that's why you can't see it, but and also the labeling is off. So that's an effective way to isolate many objects, whether they be in an assembly or just a group of objects that you've selected. You can isolate them in a particular model object, create that object, and then manipulate it through presentation or labeling, in depth position, everything that you can basically do in this representation menu. And that's very, very helpful. Another thing to remember is that anything at the top of the list is processed first. So let's say that hypothetically I had one of the components in the ladder cage, and I inserted it into this list, and I put it up higher. It would actually be processed, and the fact that it existed here wouldn't matter at that point. It would only be processed, if it was above it, it would be processed in the way that I would want to present it via labeling and presentation, depth, position, geometric or restriction, on and on. So again, anything that's particular, that you have a particular condition for, you need to put it at the top of your presentation list, because that's how it handles it from the top down. All right, so basically everything else here is just my standard labeling, the things I've created, and then the presentation. And remember too that the presentation is important for the dimension requests. If you hide system lines, sometimes the dimension requests obviously won't work if they're based on a system line to work. So you've got to remember that when you change your presentation, keep in mind that if you have dimension requests that require a certain type of presentation, if they disappear, then that's your problem when you're troubleshooting. One thing I did here was I left a lot of this stuff from a copy in, and it's really kind of inconsequential as far as how it affects this drawing style, but you can go as far as to clean all this stuff out and only put the stuff that you're working with in your drawing style. And when I finish this drawing style, I may do that. It's just about having things that are tidy so that you can go back and troubleshoot them if you need to. Okay, so enough of that. Just one last thing on the front cage. That view showed the cage and had the entire ladder as an environment feature display for the printout. And you'll notice here that if I go there and then I go to the representation, ladder all objects is at 9, and you'll notice here it says visible hidden environment. Labeling is off. So basically that took the entire ladder and minus the cage, of course, because that was the focal point of that particular view. It took the entire ladder and it put it into an environmental display state. And again, if I go over to model objects here and go to ladder all objects, you're going to notice here that everything to do with that ladder via the model roles is in there, and so that I can quickly manipulate it to its presentation, whether it be in labeling or the graphical presentation itself. All right, so let me talk a little bit about the dimension requests. This is probably by far the most difficult thing in advanced steel. And the funny thing about it is you'll find that when you get used to using the tools, you may not necessarily be able to explain to anyone what the hell you did, but you can get there. It's almost like kind of an intuitive language after a while. So I'll do my best to explain what's going on here with these, and I'll just use this front view as a starter. Okay, so you see the ladder, it says front view, CSW. That's my view here. I'm going to go over here and go ahead and pull up this view dimension. Okay, let me kind of make this smaller so I can kind of help you see this. Okay, now the first dimension here is it says main part X, ladder platform top, mid platform angle. And what that means is that the dimension direction is in the x-axis of the main part, which we just saw in the earlier example when I showed the construction plane for that assembly, which is basically the construction plane for that main part. And it's in the x direction, which is this way, okay? And the ladder platform top is this. It's this model roll right here. The mid part is this part, and then the platform angle is the bottom. Now, if I drill down into this a little bit, you're going to notice that it says x-axis of main part, which means the x-axis of this part here, the main ladder profile, and that's the dimension direction. Now, the ladder platform horizontal, it says ladder platform horizontal top extreme. Okay, let me kind of move this out of the way so you can see it a little bit better. Model objects are ladder platform horizontal top, which is this guy right here, and it says it's extreme size of the objects. But remember that there's a condition on the actual selection of the points, which is extreme bottom left, okay? And if you drill down into this guy a little bit more, you're going to be able to see that there's no geometric restriction, but the point position relative to the object center is the bottom left, okay? And I don't, but basically an extreme size of the objects in the dimensioning direction, which is this graphic representation here. So in order to understand where this point winds up, if you'll notice this set of dimensions here is basically what's described by this request, okay? And this point right here that's grabbed is basically the bottom left if you turn this part up, okay? And that's kind of hard to get your head around, but it's what it is. It's the bottom left. If it was the bottom right, it would pull from here. The bottom left, it would pull from here. So looking at this graphic here, you can see that as this graphic states, it's basically the bottom left, which is the shaded blue area. But remember that you have to actually rotate that part up in your head to kind of get an orientation view on it. It's a little confusing, but that's how I understand it. And so that's how you have to kind of digest it mentally. Okay, and then you've got your next dimension here, which is, let's get back to this one. This is the next one, the next set, the next point request is ladder platform horizontal, which is this guy right here, this tube, extreme size any. Now, extreme size of objects in dimensioning direction, which means it would go for the extreme size in the dimensioning direction, which is the x-axis, main part, x-axis. And so basically on either side of this is the extreme size. You'll notice that I have any, which is the point position relative to the object center, which means it's going to grab both of these points, okay? If I were to select something different there, then most likely it's going to grab just one of those points in the extreme size. So when you select any, it basically selects all the points available in that direction. Okay, and then the next the next one is the ladder platform angle, and that's basically this guy right here, the angle itself. And it says contour bottom right. So what I'm doing is I'm using the object contour as a reference. So if it exists, it's going to grab it. If it doesn't, it won't. And it says bottom right. Okay, so basically what that's doing is if you were to take this angle here and turn it up, then it grabbed the bottom right, which is right here. So now when you look at this icon once again, it reflects that the blue shaded area is at the bottom right. Now again, remember you have to rotate that part up to have that orientation really make any sense to you, but that's basically what it is. And that is one of the more difficult things in the drawing style manager as far as point selection goes, is to actually be able to visualize this stuff in 3D, the spatial awareness of the parts as they relate to the points that you're trying to grab. So this icon actually helps, but you've got to kind of latch onto it mentally and kind of retain that in your head. And it'll come with practice, but again, it does take time. One thing I want to add is anytime you're going for a dimension, and I learned this from Oliver in one of the previous trainings that I attended in person. Basically, what you want to do anytime you're going to start with a dimension, first of all, you're going to have two unique points to make that dimension, but also which points do you want to be dimensions. The best thing to do is to start out with every one of them that can be dimensioned, to see if you can actually even obtain the results you're looking for. But because if you push this, if you select this, all points that are to be dimensioned of the objects, if you select that and you don't see in that group of basically a mess that you make, as far as the dimensions go and the point selection, if you don't see what you're looking for, then there's a real high probability that you're just barking up the wrong tree and wasting your time trying to get a particular dimension that you're after. Because if you can't get it with all the potential points that can be dimensioned, then it ain't going to happen. You're going to have to figure out another way to do it. So that's just something to keep in mind to keep you from barking up the wrong tree for literally hours. I mean, you really need to know as you you're trying to create your drawing style. So with that in mind, that kind of takes care of the explanation of this dimension. I'll try to make these a little quicker. The main part, Y, it says ladder platform to ladder profile, left gap. Basically what that is, and then there's a right gap, it's these two dimensions here. And if you'll notice, I wanted to show the offset from the platform angle to the stringer, because there needs to be an offset here. It just can't be out to the end, because it's a very strange feeling to put your foot over that ladder and to have something kicking into your shin. So you want to have it in a little bit. But if I go and look at this, we've got ladder profile short side, and that's this guy over here. Remember we talked about that new model roll that I put in there. And ladder platform angle extreme top right. Now this is reflecting this angle right here, the extreme top right. Now again, you'll have to experiment with grabbing points, but this is basically how I came to that part. And remember, it's the y-axis of the main part, which is this way, okay? And that's why that dimension is like that. All right, so again, we have those two there, that the right and the left gap. Now here we have a main part X assembly overall plus ladder steps short side, and this is GBA, and this B is for the bottom, basically the dimension to be on the bottom, so that it hangs out in this area instead of up top. And that's one of those things that I'll explain it to you kind of quickly. There's a section through here. It says arrangement on the drawing, and basically, if you'll notice here, arrange the dimension line above and not below. Well, right now I don't have that clicked, so it's going to be on the bottom. So as it relates to the object here, it's going to go to the bottom, okay? If you were to click this and make the dimensions up top, then it would go on top and it would create some clutter here. So you've got to make that decision when you're setting these up to try to avoid clutter and having to move them afterwards. You want to have them fall in the right places as best you can. So basically, what this one does is it gives you it uses the top platform horizontal, and it also uses the angle, the platform angle, and then it uses the rungs themselves, the system points of the rungs, and then it uses the bottom of the short side ladder profile. And what I get in the end is a pretty cool deal here, where I basically have the distance between the top of the grating and the top of the ladder, which is code, which is 3'6", and then I also have the rung spacing as it relates, because obviously from the platform to the first rung it's got to be 12 inches, and then so on all the way down. So basically it gives you a running dimension which can be easily hooked with a measuring tape, so that the fabricator can lay these profiles out, and using your dimensions, he really doesn't have to think much, because anytime we start doing manual math in the shop, some guys are better at it than others, and some guys screw it up royally. So you got to be careful about that, and you got to try to provide them the best information you can, so that they don't have to really think that much as far as making manual calculations and things. So that's what I've done here. Just a note, a very important note here, is that you'll notice that this is a hidden object, okay? It's got the green hidden line color. Now you'll notice here that you have the opportunity when you pull these points to go into the let me show you here. Now I'm kind of getting a little short on real estate here. You've got the opportunity when you pull these points to be able to grab points from something that's visible, something that's visible and hidden, okay? And you'll notice here that on my ladder step short side, okay, I have my visibility status set to visible and hidden. If you don't have it set there, it won't grab the points, okay? And a lot of times something won't work, and it can be something as simple as that, and you'll go off on a wild goose chase and you can't figure it out. So remember that when you're trying to do a dimension request and pull some points from objects, if they are hidden, you want to go ahead and put your visibility status to visible and hidden for your point selection on that particular object, because if you don't, then the points aren't there as far as advanced steel is concerned, and it's a very important thing to know. Also, sometimes the order in which you place these makes a big difference, so you're going to have to experiment. I mean, you can basically set those orders up through these arrows here, and remember, if you want to delete the first one, you always have to move it down one, because you cannot delete the first entry. So basically what we have here is without going into a heavy explanation, I might make a video on how to do these from start to finish, maybe one, because like I said, it takes a while, and once you learn to speak the language, then things become easier. But to sit here and try to explain it to you, it would take a long time. So anyway, you kind of get the gist that you're going to have to experiment, but this stuff is incredibly configurable. I mean, we did some Tekla training a while back, and basically, I'm surprised at just how much more you can do with advanced steel. But advanced steel's got some issues as far as the large model handling and some of those things. But with the latest hotfix, which was hotfix 2 for the 2018 version, they have fixed some of the problems, and I really think things are looking up, man. I'll tell you, for advanced steel, and I had an opportunity to go completely over to Tekla, and as far as the miscellaneous metals in advanced steel, it blows the doors off of Tekla, and I never thought I'd be saying that, but it really does. So for the ease of doing miscellaneous metals, there's just no comparison, and so that's one reason to really stick with advanced steel, because it's a great program for miscellaneous metals. So anyway, this kind of explains some of the stuff that I was talking about. You notice how a lot of my dimensions, where I need to label them, I go ahead and show the labels, and you can type in basically anything you want to with these things. And you'll notice here, as I go through to the dimension label tab, if I go down here, you see rung spacing on both sides, the ladder rung to wall connector, basically the space between the midpoint of the rung and the wall. I've just labeled that as typical. But another trick or method to understanding your dimension request is when you are trying to create a dimension, first of all, you want to make sure that you go ahead and expose the label content and write whatever you want in there that'll allow you to recognize what you're doing. You could actually copy the actual name of the request in there, or you could you could give it a name that you understand. But then what that does is that will show you those labels on your dimensions, so that you know what's working and what's not, because otherwise it's just going to be a shot in the dark, because by the time you get back to that interface, man, it's like you've forgotten half the stuff that you're trying to look at in the first place. So what you've got to do is you've got to create a scenario for yourself where you can test this stuff quickly, or as quickly as possible, and go ahead and make your changes and see how those changes react. And I plan on doing a video on the drawing styles for some railings. I just recently created a really nice drawing style for picket railings, some standard industrial stuff, and I'll tell you, it works great. In closing, I'd like to thank you for watching the video, and I hope it furthers your understanding of Advanced Steel's Drawing Style Manager. Please give me some feedback and/or any questions. I'll be happy to try to answer them for you. In the meantime, happy detailing. Take care.